Okay, so today we're going to look at 5b, part 1, because we're going to have a whole second section of this that is completely different. It's finding distance for 2 points that are on the same meridian. And meridian is simply another way of saying longitude. And we mentioned last time that the shortest distance between 2 points on Earth, or any sphere for that matter, is on the great circle that connects them. So the shortest distance between 2 points on Earth, or any other sphere for that matter, is on the great circle that connects them. And if you connect east and west longitude, you get a great circle, right? What's the only latitude that's a great circle? The only horizontal one that's a great circle? The equator. Good. Okay. So, but all of the lines of longitude, if you connect the two, east and west, then you get a great circle. So that makes your life very easy. Because if it's a great circle, we can make a drawing of a circle, and then we can use what we know about circles to find distance between 2 points. Because those distances between 2 points, let's just say for kicks, Dallas, and now there's no way this works. And Brisbane, the distance between them, if they were on the same longitude, which we know they're not, right? But if they were, the distance between them would be the arc length at this point, right? And since the Earth is a sphere, but if you cut a big chunk out of it like this, then what we've done is we've created a circle. And what do we know about the size of the Earth? Do you think it changes much?
No.
Not really. It does change. As you move around the sun, it does get a little bigger and a little flatter. But for our purposes, we're going to use it. We're going to use the average circumference of the Earth. And the average circumference of the Earth doesn't change. Okay? So in that case, what that means for us is that we know the radius of the Earth at any point. Does that make sense? If it doesn't change, we always know it. Okay? We don't care what it is, because we're not going to use it in a formula. But if you did know what it was, we could put it into that arc length formula. But we're going to make your life even a little easier. Okay? We also know that the equator is 0 degrees latitude. And that the equator is also a great circle. So it's passing through the center of the Earth. We also always know that latitude tells you how far north or south from the equator. That's what lines of latitude do, is measure distance from the equator. So let's say, for example, that Dallas is 27 degrees, and since it's above the equator, that would be 27 degrees north. Let's say that Brisbane is 35 degrees south. Now, I'm making all this up. This is not true. They're not even on the same lat of longitude. I'm just using 2 names. Okay? Well, if that's the case, then I can draw a line from the center of the Earth to each of those points, and I've just created 2 little sections that I can now measure the arc length of. And if I know the arc length, that is the shortest distance between those 2 points. Okay? Now,
There's no straight line between 2 points.
Right. So we have to always measure in a curve because we're talking about a sphere. Okay? Now, but we know the distance from the center of the Earth to the edge of the Earth is consistent all the way around. So the radius is going to always be the same. So someone in their genius way of thinking said, if we did arc length with the radius of the Earth and pi, and if we use the formula and just replaced it as 1 degree, then we would have a fixed number of distance for every degree, right? Because 1 degree is not going to change. If you have 27 of them, that just means you need to multiply that 1 times 27. So it makes your formula easier. So here's what happened. They did that, and they found that the arc length for 1 degree on Earth is about, not equals, but about 111.2 kilometers. So no matter where you're measuring, north, south, it doesn't matter. It's always going to be 111.2. So for example, let's say, go back to that Dallas example just for kicks. We say that it's 27 degrees north latitude. Then from the equator, which is at 0, right, to there, that's 27 degrees of latitude. And each degree of latitude is how many kilometers? 111.2. So to find the distance from the equator to Dallas, all I need to do is take 111.2 times 27 degrees. Anybody got a calculator? So 111 times 27 is going to give me 3,000 what? 2.994. Thank you. 3,000. Sorry. So 3,002.94 kilometers. All right? So if we find lines that we're looking at points that are on the same longitude, all we need to do is find the degrees, and then multiply those degrees times that constant. Okay. Now I do need to know though that these are approximations, so it's about. You cannot say that Dallas is exactly that distance. You need to say that it is about that distance. So make sure that you keep that in mind. So what we're going to look at is a couple of scenarios where we're going to use these. So let's just go back to our original example there. Say we had city A and city B. Line through the middle of the Earth is called the equator. Make your drawing. I can take you back and show you copies of old tests where you can clearly see that students knew what they were doing. They knew the multiplier. They knew how they were supposed to multiply by the number of degrees, but they didn't get the right number of degrees because they didn't do the drawing. Watch what happens. If I have this going from the center of the Earth to both points, if this one is 27 degrees and this one is 30 degrees, remember the equator is at 0 degrees, I can't just measure the whole thing. I don't know this whole angle yet. But I can easily find it because if I'm going on both sides of the equator, that means I'm going to be doing what? I'm just going to be adding them, right? I've got 27 up there and I've got 30 down there. So if you're crossing the equator, add the numbers. So it's simply going to be 27 degrees plus 30 degrees, so 57 degrees. So that means that the whole angle I'm looking for then is 57 degrees. And my multiplier stays the same. Somebody want to multiply that out for me, please? Sorry? Seems a little small.
That's 6,338.
6,338.
6,338.
There we go. And kilometers, and remember it's always about, never exact. Okay? All right. So finding these amounts are dead easy if you let it be. But the key is to make this drawing. Right? Because you have to know what it is or what measurement you're looking for. Let's look at another example. Say, for example, we have cairns, and I don't want to hear you make fun of me say that, at
No, that's actually.
Wait, so what did you say?
20 degrees south, cairns. I can't help it.
Just take out the I and the R.
Cans.
Cans. Say cans. Like a Coke can. Say cans.
It's not spelled that way. I'm not doing it. And Melbourne, which is 35 degrees south. All right? So now they're on and we know they're on the same line of meridian. Okay? So we can just place them on a circle. So let's say that that's Cairns and that's Melbourne. The equator is in the middle at 0 degrees. But what do you notice about both of these points? Is one above the equator and one below? No, they're both below. So what I'm doing is I'm looking for this distance between them. So what I have to do is, I don't want all this distance though, right? So I need to find, and I know that this is 35 degrees and this is 20 degrees. So I need to find just the part I'm looking for, so I need to take some of it out. So what operation am I going to use to take some of it out? Subtract, right. So if they're both on the same side of the equator, subtract out what you don't need. So in this case, it's 35 degrees minus the 20 degrees tells me that the distance between them here, this part, is 15 degrees. And once I know the number of degrees, I just use it with my multiplier. So it's 15 times 111.2 kilometers. Someone please?
1,668.
No decimal? Okay. And of course, we can't call it equals. We have to call it about. So use the little squiggly equals. Okay? But look how easy it was to know exactly what it was you're trying to find if you will make the drawing. If you don't do the drawing, then you can get yourself into some trouble. Okay? Now, focus, because I'm going to call on somebody to answer this question. So if I'm going to sail around the world, would I be just sailing this little 15 degrees that I've got here? If I was going to sail around the world, that means if I was starting in Cairn, I would be going all of this distance, right? Okay? So that whole distance is 360 degrees. I won't be traveling that little distance between them, so I'll just subtract out that 15 degrees, which gives me 245. So be careful about the way they ask the question. Now look at that though. I was able to use 345. Sorry, I can't add, subtract, multiply, or divide. All right. So pay attention to the way the question is asked, but look at how the drawing made it really clear what you needed. If you were going to sail from there all the way around and back, right, then you would need the other part. Well, stupid if you're trying to get there fast, not stupid if you're trying to be on vacation. Right? Okay? All right. So we're going to look at a couple of these. We're just going to go to the exercises and do some examples. So for any problem, your first steps should be to identify if they are on the same great circle. Because you can use latitude if they're both on the equator, right? So it's not only limited to longitude, but you can use latitude if it's on the equator. But if it's not on the equator, if they have the same latitude, that is a completely different process. And that's the one we'll learn next time. If they are on the same great circle, identify north, south, east, or west. Where are they in relation to the great circle? Okay. So again, remember, you can do this same exercise on the equator. It's the only one of the latitude lines that would work. 3. I don't know what the heck that was. Make a drawing. If you don't draw it and your answer is wrong, I'm not going to sit there and try to figure out what you meant. I'm going to go, didn't care enough to try, wrong. Right? It's that important that you make the drawing. So make a drawing. Label your points. So on your drawing, you'll label your points. Then you're going to add or subtract as necessary. If one of your points was on the equator and the other was north of the equator, would you have anything to add or subtract? Nope, because the equator is your line of demarcation there, right? Then you'll simply multiply by 111.2 kilometers. And finally, round if asked. If you don't round it and you were asked to round it, then you're going to lose some marks. Okay? All right. So the only way to get full marks is to show every bit of this. And I don't care how easy it is, every bit of this. All right? So let me show you what I mean. So first, we've identified that it's 22 north and 35 south, and the question told us that they are on the same meridian. We don't know what meridian, we don't care. So we just draw a little circle. Now, you'll see in some teachers in some books, what they'll do is they'll put one up here and then one down here. I don't like that. It doesn't look like arc length to me. Instead, what I like to do, and you can, but I want you to have the option because it's your life. Instead, I always draw the equator here, and then if it's north, I'll put it on this edge, and if it's south, I'll put it on this edge. Then when I draw it, it looks like arc length, right? Like what you're used to. Otherwise, you start getting into that 3D geometry. It looks a little funny if you put it in the center to me. But you do what you want to do. Now since I'm crossing the equator, that's 2 values. But I need to turn them into one value by doing what? Adding them together. So 22 plus 35 gives me 57. Once I know that value, then it's simply a matter of taking that 57 times my multiplier, which is a constant, and 57 times 111.2 becomes 6338 what? 0.4 kilometers. But they asked me to round this to the nearest kilometer, so I'm just going to round that 4 off and have it at 6338. 3.38 kilometers. Isn't it? It's nice.
So what about taking steps?
Okay. All right. So that's the process. Let's do some together. So I'll stop the recording now.